You are climbing a staircase. It takes n steps to reach the top. Each time you can either climb 1 or 2 steps. In how many distinct ways can you climb to the top? So what we're trying to do is we're trying to find how to get to the nth step. We're given some number n, and we have to either climb 1 step at a time or 2 steps at a time to get to some number n steps. And we want to know how many different ways we can get to the nth step. So in our example here, we're given the number 2, and in the explanation, we're able to move 1 step twice to get to the second step, or we move 2 steps to get to the second step. So here we have a staircase of size 5. So we have 1 step, 2 step, 3 step, 4 step, 5 step. Now there are only 2 actions we can do. We can either just do a 1 step or we can do a 2 step. And we can do this from any step. So we can do 1 step, 1 step, 1 step, and 1 step. Same thing for the 2s. We can 2 step from any stair. So we can do 2 step, 2 step, 2 step. So this is getting a little messy. Let's visualize this in a different way. Let's make this into an array. So let's do something like this. This is the ground floor. This is where we originally start from. This is our first step, second step, third step, fourth step, fifth step. And from the ground floor, there's no way for us to actually get here. So we're just going to say there's 0 ways to get to the ground floor. And at this point, you might be asking yourself, all right, this is great and all, but I only really care about the nth step. Why do I care about any other steps that come before it? What we're getting to is something called bottom-up dynamic programming. So to find our answer, we're going to build a bunch of little answers to get up to our bigger answer, the one that we want at the end. So again, this is our ground floor. This is our first step. And to get from our ground floor to the first step, we can only just do this one operation of 1 step. So this is going to be just one way of getting here. For our second step, again, we can just do this one operation, or now we can finally do this 2-step operation. So this is our second way of getting here. We can either do the 2 1 steps, or we can do the 1 2 step to get to this position. Now, here is where the magic is going to come in. First, let me get rid of these arrows. To get to this third position, there's only 2 ways of getting here. Again, we only have 2 actions. We can either take this 1 step or we can take this 2 step. There are 3 ways of getting here. And why is that? Because we just shown that there are 2 ways of getting to this step and then only 1 way of getting to this step. And we have 2 actions to get to this step. We can either do that blue 1 step or we can do that orange 2 step. So what we're saying is that because we can do this blue 1 step or this orange 2 step, to get to this third step, we just have to take the sum of our previous 2 steps. Let's do our 4th step now. We can either do this 1 blue step or we can do this orange 2 step. Because we have 3 ways of getting here and 2 ways of getting here, there are going to be 5 ways of getting here. And then finally, at our last position, using the same logic, either the 1 step or 2 step, we're just going to get an 8 here. So again, at any step, we can just use this same logic. We can either just do this 2 step or we can do this 1 step. And the total number of ways of getting here is always just going to be the sum of those previous 2 values. So this is the nth step. We're just taking the combinations of the n-1 step and the n-2th step. And again, building up to this final answer in this way is called bottom-up dynamic programming. It's building on smaller answers to get up to larger answers. So let's start programming this. First, let's just create a dictionary. So d equals default dix int. If you don't know what this is, it's just a dictionary. It's just a better version of a dictionary. I'm not going to go into the specifics of it on this video, and we could get away with just using a regular dictionary like this, but I want you to see this and start using this instead. Now let's start putting in some of our smaller cases. 1 equals 1 and 2 equals 2. Again, this is just on step 1. There's only 1 way of getting there. And on step 2, there are 2 ways of getting there. Now we're going to solve every case until we get to our nth step. So for I in range 3 to n plus 1, we need the plus 1. Otherwise, n wouldn't be included in this range. And we say d of I, whatever our ith step is just equal to d of I minus 1 plus d of I minus 2, where ith step is equal to our previous 2 steps, because again, this would be our 1 step, this would be our 2 step. And then finally, after we build up all of our answers, we can just return the one that we care about. Return d of n. We can run this, we can submit it, and there we go. So before we go, I want you to understand that this is an incredibly important problem to understand. The techniques and the understanding of what we do for this problem is going to be fundamental for other problems that we attempt. If you found this solution helpful, please consider liking and subscribing. See you in the next one.